there, it's Sunday morning, and I just released a video on building this, the second CNC build I've been involved with. This is using parts from the original Stepcraft, the stuff that was left over after I rebuilt it to begin with the big version, this being the small version, or the baby, that will be exclusively for cutting metal and plastic, mostly metal. All right, so I don't expect I'll be using it like a lot over the next while, but in preparation for all this metal machining, I actually bought some metal. I bought 2 sheets, 1/4-inch aluminum to potentially build a new table saw, being one project, and potentially build a radial arm saw as a potential project. These will obviously be big projects, and assuming I do them, they'll be starting this summer. But in the meantime, I did buy the aluminum, and I actually cut a little bit off the end of the first sheet to use to make parts for this. And I also made the base plate for the router, which I haven't got in here, which is a shame, but I showed it in the actual build video for the thing. Now, I didn't make one of these videos last week when I made this thing right here. This is my loose change or spare change, dead blow mallet. And this was kind of interesting because it was the first project on the rebuilt CNC. Now you might be saying, oh, John's going all high tech on this here. He's not going to be doing any more traditional woodworking or anything like that. And that's simply not true. I explained my rationale for rebuilding the CNC in that video. And basically what it boils down to is that I've got the thing from the Stepcraft one, and it wasn't working reliably. It was giving me too many problems. I thought it would be a good investment of my time to rebuild it in a way that I was in control. I can't say that I'm a control freak, but I like to be in control of the things that I own. I like to, all of the tools that I have, I like to be able to repair them. I want to know how they work, exactly how they work. And the best way to do that, of course, is to build it yourself, right? So you build your table saw, right? You build your bandsaw, you build all kinds of things, and you know exactly how they work. That's the way I like to have things. Anyway, so the mallet is here. I haven't actually used it for anything because basically, I went from building the big CNC, and even before that was finished, I started working on this because at some point I had to bring the big CNC down from the kitchen where I was building most of it. And that freed up space on my island up there to start working on this. If you watched the video this morning of me building the CNC, thank you. I appreciate it. And if you haven't, there's a link in the description of this video, and it will be at the end, a link at the end on the end card type thing. You can go and watch it there. If it's not showing up in your feed, which it probably isn't. And, I'm at the point now where the views it gets. I don't really care that much. I can't say I don't really care. It's just that it doesn't bother me. If the video does poorly, it's going to do poorly. I'm not going to lose sleep over it. If it does well, it does well. It won't though, because of the topic and because of the age of my channel and the lack of engagement of the viewers on my channel. Same thing happens with every other older channel. They lose engagement over the years. I've talked about this ad nauseum in the past, so I'm not going to talk about it here. Anyway, so like I said in the video, I'm spraying coolant on there. This is just soapy water. There was a little bit of Windex left in the bottle, that gave it that blue color. Okay, but I just put water in there and I put soap. But the idea is to run a flood coolant system, and I got a little cheap little aquarium pump here, and I 3D printed a bushing that fits inside this thing here, so I could adapt this 1/4-inch hose. And on the other end, I 3D printed another adapter, you could say, that takes that hose and gives it mounting holes, so I can mount it on the Z-axis, and also connects to the flex thing that comes out that has the valve on it. Okay, so yeah, I'll be doing that soon. I got almost everything ready to do it, but I'm not going to put that in the video. What you'll see from this is parts being made in the future. Okay, parts for the fantasy table saw that I hinted at I'm thinking about making, and parts for other things that need metal. Okay, you know, for a long while I was deep into the 3D printing, and 3D printing is awesome, but the big downside with 3D printing is the strength of the parts. And with the system that I'm working with here, with FreeCAD and then 3D printing and then CNC, you can take the same model that you drew in FreeCAD and either 3D print it, or you can machine it on the CNC, depending on how complex it is, that is, right? That is the ultimate for someone like me that wants to be making stuff that is strong, and also not spend, 2 weeks making a part that this thing here can make in minutes. So if you did watch the video, you'll know that my spindle conked out. The brushes have gotten bad. Now this is a high quality spindle. This is actually made by Mafel, which is a German company, high-end tools. And it's kind of a shame that I can't use it because the brushes, they're removable, and I can take them out and replace them. And I'm sure that I could probably, if I looked, I could probably find something close enough to use in here. And maybe that's what I will do in the future. But in the meantime, I took this off the big CNC, and you might be saying, well, what do you got on the big CNC now, John? Well, I'm so enthusiastic about this big CNC and how well it's working, I bought a proper spindle for it, and I got that put on with a VFD to control the speed. I also ordered and got the boards that will connect Mach 3 to the spindle, so I can control the speed and turn it off and on eventually when I get around to wiring those up. So that's good stuff. And in the meantime, I'm going to hold on to this. I mentioned in the video about the collet. Right here I have the 1/8 inch collet, and the 1/4 inch one is around here somewhere, but the 1/4 inch one is messed up. The problem, the way these things work, the way this collet works is it's two pieces. It's got the nut and the collet that snaps inside, very much like the ER type ones, except there's not very much gripping onto this, and it relies on this nut to not only tighten it in, but also to pull this collet out of the taper. And I messed up the 1/4 inch one by cheaping out and using a 1/4 inch drill bit as a bit. And the shank on the 1/4 inch drill bit must have been a little bit too small. And when I put it in and tightened it up and then went to take it out again, it kind of ruined the edge on the collet. So it made it very difficult to come out. And then when it did, it was still stuck, like it was wedged tight in the nut. So I would have to pound the nut off to get the bit out. So, and then like I said in the video, and like I said here with the brushes for this machine, you can order a new collet, but the shipping is astronomical. The Coolant itself was like something like, I don't know, 20 euros. But the shipping was over 100 euros for a little chunk of metal like that. No way am I doing that. And it's the only option for this spindle because it's made for this, right? Which is not standard. I mean, if it was an ER11, ER16, ER20, that'd be fine. You can order those on Amazon, you know, get a replacement on Amazon and you'd be back in business, no problem. And cheap and free shipping. I love free shipping, but no, not for this. So yeah, my priority is not on this. You know, if I can fix it, if I can get it running again, I'll find something to use it for. But otherwise, it's just going to sit around. Now, a little bit more detail on the CNC is that I didn't have to buy very much for it. I had a lot of stuff already. Like I said, I used a lot of the parts left over from the Strapcraft. I used the original motors, the rails, the linear guides. I had one linear guide bearing that broke when I took the machine apart, and I tried to find a replacement for that. I ordered two on Amazon that looked close, and when I got them, they wouldn't fit on the rail, but they would fit if I took the balls out, which are slightly bigger, and put the original balls from the original bearing in, and that's one of the ones on the x-axis. And the lead screws being 3/8 inch threaded rod, probably a better choice for that would be 1/2 inch threaded rod, a little bit coarser threading on that. This is 16, 1/2 inch is 11 threads per inch. And that would give you, like, I'm not having any whipping problems on here, but I'm not driving this any faster than 40 inches per minute. That's the maximum speed I can go on this without the threaded rod slapping a bit, you know, whipping. And like I say, if I had my time back, I would use 1/2 inch threaded rod. That would be what I would suggest if you're going to go that route. Most people won't because they don't like to take chances on these things. I don't mind doing it because, like I said in the video, I don't have anything to lose, right? Same with the bearing that I made for the Y rails here from aluminum. If it wears out, it wears out. Eventually, maybe what I'll do is I'll, you know, rebuild another machine using this machine to make the parts for another machine and use big, chunky, linear rails like I used on the Z-axis. And like I said in the video, I used those on there because I had them, first of all. And also, you know, they're 5/8 of an inch wide, like 16 millimeter hardened steel. They add a lot of strength to the Z-axis that I don't have to try to get from, you know, the structure. They add all the strength that I really need there. So the plates, the aluminum plate that I put on the front here, just links it all together and keeps everything square. And as you can see in the video and also in the background right here, I'm using Mach 3 to run the CNC. I use that on the big CNC. I've gotten quite used to it, and I have a license for it, so it'll work on both machines and no issues with the length of the file or anything like that. Although, like I said in the video, I'm keeping all of the machining operations on this fairly short so that the cordless battery, you know, the cordless router that I'm using for the spindle won't go dead while it's running the program. Okay, and so far I've made a few things, including new hold downs, which I don't have here because I had them out in the shop, grinding the edge off, or, you know, deburring the edge. Everything's worked out fine. Like, the battery hasn't come close to wearing out. But like I said, you got to be diligent about changing it and not let it go.